some electronic module. One of the most important of this module is ESP12. This is the core of this device that I want to control power line. As far as you see, this is the input of the power line, and this one is go to a relay, and this relay is controlled by the ESP module. And out of this line we have an ACS 712 a sensor for measuring current of the power line. And we have control panel, a amplifier module, a ESP, a relay, a power supply, and a ACS sensor for measuring a current. And this is the real schematic of this device, and this is the input of this device. And as far as you see, you can see this is the data sheet. I sketch it to this paper. This is the input line, and we have high voltage, the AC voltage input to this IoT module, and this is the power supply that works with switching method. And in output of this power supply we have plus 5 volt and DC, and this voltage through the control panel for the distributing all the voltage and all the ground line to support all of this module. And you can see we have ESP that has a Wi-Fi module, and we have a CH340 chip that this one that is on board. This is include the ESP module, and in this side of device you can see a USB port, and we can connect this USB cable to this module for debugging. And also we can also programming with the OTA over DA programming method of this module, and control it as remote with distance according the connectivity of internet. And this control panel, you can see the schematic of this control panel here. This is this one, and include two LED and the reset button, and this is the reset button. And also we have one buzzer for notification for any alarm that related to the all the message for related to this power line. For example, if consume of this power line is higher than the our limit, this alarm notify the user that is the consumption of this power line is so high, please go down. Okay, and continue. You can see this is the amplifier board, because the output of ESP, as far as you know, the 3.3 volt, and we should amplify this voltage to the level of 5 volt for the controlling the relay, for the controlling this relay. And this relay can control the line up to 10 ampere, and also this module is a ACS sensor for sensing a current that through across this relay and go out of this module. And why we connect this sensor after the relay module? Because when connected this sensor before the relay module, this is the some problem. For example, when this relay doesn't work correct, and or this switch is corrupted, we can sense this corruption with this sensor. But if used before this module, we cannot sense any corruption of this module, and this is better to use in the after of this module. Okay, this is all the datasheet of this project, and we want to continue with the Raspberry Pi board. In this case, we have I have a Raspberry Pi version 2 model B, and as far as you see, and I have one Wi-Fi dongle that's connected to the USB of this board. And before anything, you need a micro SD for writing the Raspbian, the OS of Raspberry, to this micro. And for doing this job, first of all, I put it in a micro SD adapter and imager of Raspberry. This is the software of Raspberry Pi imager, and choose the OS. For as far as you see, the recommend of Raspberry Pi is the Raspbian, the 32-bit of operation system that's based on Debian. This is included all the recommended software that you need in continue of the project, and we select the Raspberry OS 32-bit of Debian based, and also choose the SD card. Okay, and again put it. Okay, you can see this is the micro SD. Okay, and we can choose the micro SD, and after that write the operation system into the micro SD. And as far as you see, I done this job before, and this is the final file that rated in this micro SD. And as far as you know, if you don't have any HDMI cable for connecting and viewing the output of the operation system, you should prepare wireless LAN system in the Raspbian. You need to create a SSH file that's empty without any expression, and you see this file is empty, and you should create first of all the SSH file, and after that this one, the WPA underline supplication.conf, and this file included all the information of your network, your PC that you want to connect with the dongle, or in the upper version of Raspberry you have onboard Wi-Fi or Bluetooth. In this case I have a Wi-Fi dongle additional Wi-Fi dongle that connected to the USB, and I want to connect with this dongle to my PC, and after that I control and program the Raspberry Pi with the SSH connection with PuTTY software. And you need write this sentence to this file, and also choose the country and change this one to your country. For example, if you are living in Germany, or in this case you live in Italy, you need to change in 2 bytes. For example, in Italy we have IT, and you need to address the SSID and the pre-shared key of this file, and this is my info. And you should copy these 2 files. Into the microSD of Raspberry. And after that I remove the microSD, and I connect the microSD into my Raspberry. Okay, and after that I connect to a power supply. You see I have a power bank. This is 5 ampere and so good and enough for running the Raspberry. As far as you see, my Raspberry is running, and now I turn on my mobile hotspot of my network. Now I should see the Raspbian, and I should wait for boot up the Raspberry. And yes, now the device name is Raspberry Pi, and the Raspberry gets the IP address, the local IP address. This is the IP address of the Raspberry Pi in this network, and also this is the MAC address. Okay, I done this, and with PuTTY I can connect with port 2020 with SSH, and I should write Raspberry Pi that's local. Yes, Raspberry Pi that's local, you can see, and enter. And after that the PuTTY wants the username of the Raspberry Pi. By default is Pi, and also the password is Raspberry. Okay, I connect, and before I do anything, in my opinion the graphical interface is so better, and I prepare to connect with VNC to see the graphical interface of the Raspberry. And for this reason, this is the GitHub. You can see all the file, all the needed file, and also everything in this URL. This is the URL of the GitHub. Okay, and first of all we should setting up a wireless LAN, after that the VNC network, and also in continue you can see I want to connect and I want to set up MQTT and connect this IoT module with MQTT. Okay, and for the for set up the VNC, I should install the Tight VNC server. You can do with superuser do command, and after that apt-get install Tight VNC server, and I install this. Yes, I installed this, and I should start it with again super user do type WinC server, and I start it. As far as you see, this is the connection of VNC, and with the tight VNC connection, you can see this one is the desktop Raspberry Pi 1, and I connect this tight VNC connection with Raspberry Pi 1 connected, and this is the password of the VNC authentication. And now you can see this is the graphical interface of the Raspberry. Okay, after that I should install something, and I can now close the SSH because I have better connection, better graphical interface. I should install something. For example, first of all I should install Node-RED and also Node-RED dashboard, and after that the MQTT broker. In this case I install Mosquitto, and for install Mosquitto you see in the readme of the GitHub. This is all the things you need, and for installing everything, this is the command of installing Node-RED, installing MQTT. And for example, for installing MQTT, you should use this one, and for installing the Node-RED you should use this command, and in continue for Node-RED dashboard and so on. Okay, we assume you install all the prerequisites, the Mosquitto and the Node-RED and also the Node-RED dashboard, and we run Mosquitto. Okay, and for the topic, I should say first of all I need the Arduino file that we want to upload it into the ESP32 core, and after that all of the procedure controlled by the ESP module. And for doing this you need an Arduino code. As far as you see, I use ESP8266 Wi-Fi as a library, and also the two library for MQTT. And you need implement your data into this code, your SSID, your password for connecting the ESP module to your network that has a ping of Raspberry, and also connect to the same network, and so on. To continue, you can see connect to Wi-Fi, connect to MQTT, and also for the void loop of Arduino, we can get the analog read of the sensor of ACS 712, and after that we send the data as a publisher to the MQTT broker, and we can see in the Raspberry side. Okay, I open this, and I select my board. My board is ESP8266. You can see this one, and I should connect cable to the to the ESP. Yes, connected. And you can see, yes, the COM3 is selected for and activate and selected for this connectivity. And I should compile and upload to the board. And this side of the screen, you can see the result of compile. Okay, now compiling, and also you should wait for compiling correctly, and after that uploading this program to the ESP. Okay. Okay, now you should see the result of uploading. Yes, the procedure of uploading is started, and now you can see the data uploaded into the ESP module. Okay, and after that, in the okay, and everything is okay, and the only thing you should reset the module first time. Yes, and this is okay. And you can see the topic of the this project is ESP, and the name of sensor, and also the topic, that is ESP ACS number of sensor, and also this one. And you can see the data is achieved by the side of ESP module, and this is the analog data that read without connecting the line power, and you can see this is very low, and this is proved, and this line is disconnected to the any power line. Okay, and this is the Mosquito run and getting data. And for Node-RED, I should start the Node-RED. I should start a Node-RED. Okay. Okay, now Node-RED is started, and go to the, and I can go to the browser with first of all I should getting the host IP of the Raspberry with command host name dash capital I. You can see, and this is the IP. This is the IP for connectivity. Okay, now Node-RED is running. All of this delay is related to the capacity of processing the Raspberry, because my Raspberry is the version 2, and the CPU and the RAM of this board is lower than the other version, and because we have a delay, due to this reason we have a delay. Okay, you can see this is the all the things in flow 1 of Node-RED, and this is the MQTT in. You can see I connect to the last topic. I said ESP-ACS 712 current with local host and port normal 1883, and also I connect it to a function for compare the current and measure the current for getting information about the consumption of power line. If the consumption of power line is so high, you can see this is the LED of this tree is the user interface for Node-RED, and I have engage and chart and LED. This LED is for notification for the alarming, and this chart and this gauge for online data for the showing the data of our measuring. Interface of this project, we should add UI at the end of this address. Okay, you can see this MQTT is connected, and this is the dashboard, and finally this is the output of this project. You can see this gauge is show this line is disconnected to any power line, and if change the situation of the analog data, you can see the data is the input data is different, and if you go higher than the limit, you can see the LED, the situation of LED changed. Yes, you see the LEDs work for very high consumption, and this is the final project of IoT. Thanks for your attention.